Hello learner, welcome once again to Manifested e-learning platform, and we are going to continue with our topic on reflection and congruence. So today under reflection, we are going to look at reflection in the Cartesian plane, and in that Cartesian plane we shall look at reflection in the x-axis, or the line y is equal to 0, and that is that line. This is what we call the x-axis, and that is the y-axis. So it is also called the line y is equal to 0. The objective of this lesson is to enable the learner to get images of objects on the Cartesian plane when using the x-axis. So as already said, the line y is equals to 0 is the same as the x-axis, horizontal. Y is equals to 0. At this point, it will be y is equals to 1. But at that point, it is y is equal to 0. So this is also the x-axis, and that will be the y-axis. So in our topic today, we are interested in getting images of objects when reflected in the x-axis. So to proceed, we should have a number of images, objects. So we shall have the object, and below we have the image. So to enable us do that, we should have that table. We can have an object represented by coordinates 2, 3. You can have another one represented by 3, 1. We can have another one represented by 2, 4. Another one, -3, -2. Another one, -5, -1. So we are going to note first of all where the objects are. So the first object, you can even give it letters, A, B, C, D, E. You want to note where A is. A, you'll come here, A. Coordinate of x is 2. Coordinate of x is 2, and coordinate of y is 3. So lengthening it well, you'll come, that is where my A is. That is where my A is. I have 2 for x and 3 for y. I have another object at B. Coordinates 3, 1. So I'll come here for x3, for y1. So I have B. I'll come to C. That one is 2, 4. In fact, C is here, just above A. I'll come to D, -3, 2. -3, -2. -3 for x, -2 for y. That is where I have my D. I'll come to E, -5, -1. On the Cartesian plane, -5, -1. So my E is here. In the first lesson, we realized the properties of reflection. The distance of the object from the mirror line, that is a perpendicular distance, will be equal to that distance of the image from the mirror line. It will be equal to the distance of the image from the mirror line. So here I'm going to mark the images using this red pen so that we get the differences. Let's start with A. We want to get the image A. Using the properties we learned, the distance from, perpendicular distance from the mirror line. Our mirror line is this axis. So let's start with A. We are at A, isn't it? So if you create a perpendicular right here, you'll drop here. But it should be, those are how many units? 1, 2, 3. It should be 1, 2, 3. We land at which point? We land at 2, -3. We shall land at, this is A prime. Because those units, 3 units are the same as those ones. And the distance, you realize, it is perpendicular. That distance is, that line joining it to the mirror line is perpendicular. The same for the image. So you get the image will be at -2, -3. 2, -3. 2, -3. We move to B. 3, 1. 3, 1. So this is the mirror line. So it will be 1 unit below. This distance should be the same distance below the mirror line. So it is actually here. So that is where B prime is. Coordinates of B prime are 3, -1. 3, -1. 3, -1. 3, you can realize what is happening. 3, -1. Let's look at C. There is something happening there. There is a negative coming there. Let's look at C. We shall conclude with that. C is here. How many units? 1, 2, 3, 4. I'll count 1, 2, 3, 4. So actually C is here. It has become 2, -4. 2, -4. At that point, you've realized what is happening. You've realized what is happening. You realize what is happening there. What happens? The y coordinate, if it was positive, it will change to a negative. It gets a negative sign. So if it was 3, it becomes -3. If it was 1, it is becoming -1. But if it would now be -2, it will now become +2. Let's move to D. Let's move to D. D is here. So reflect it along that line. We'll put it above. We'll actually put it above. This is 3, -2, so 2 units above. So it will be here. D prime, that is -3, 2. -3, 2. What do you realize? The x coordinate remains the same. It is the y coordinate that changes the sign. It is the y coordinate that changes the sign. Let's look at E. E is -5. It's here. So if you are reflecting on that line, it will move there. It will be E prime. It becomes -5, 1. -5, 1. This has changed from negative to positive. So there is something, learner, you've discovered. If you are reflecting in the x-axis, the coordinates for the image for x remain the same, but the coordinate for the y coordinate changes the sign. So you can conclude, conclusion. Conclusion. When reflecting in the x-axis an image an object AB changes, becomes image A negative B. In short, the y coordinate changes the sign. So it is very quick to notice. If I'm reflecting 6, 3 in the x-axis, what will it become, Lana? It will become 6, negative 3. If I'm reflecting 6, negative 3, it will become 6, positive 3. So it is the y-coordinate that changes the sign. It is the y-coordinate that changes the sign. So it is easy to note what happens. It is the y-coordinate that changes the sign. Later on, when we'll be visiting reflection in the y-axis, you'll notice also what will happen. So having gotten that, we can also have a triangle. Even if it was a triangle, the results will be the same, because it is the same vertices that will be representing the triangle or rectangle. So for a plane, it is the same thing that will happen. If a vertex of a plane is 3, 4, on reflecting it, it will become 3, negative 4. That is in the x-axis. If it was negative 4, negative 4, it will become negative 4, positive 4. It is only the y-coordinate that changes the sign, whether it be a point or a line. Because I would still join, this is CB. If I joined to create a triangle, it will still be the same. Creating a triangle like ABD, you'll still get the same coordinates, whether it is a plane or a line. All the vertices of that plane, the y-coordinate of the image will change. Noticeable here, 3, negative 3, 1, negative 1, 4, negative 4, negative 2, positive 2. It changes the sign. Negative 1, 1. So we summarize it by saying, when reflecting in the x-axis, an object AB becomes an image A negative B. The y-coordinate from the object changes the sign. If it was positive, it becomes negative. If it was negative, it will become positive, because negative, negative is positive. So at that juncture, in our assignment, so notice the images are represented by the coordinates. Find the images of the following points reflected in the on reflecting in the x-axis. In the x-axis or line, y is equals to 0. Notice that x-axis is the same as line y is equals to 0. So we have A, negative 4, negative 4, K, negative 4, negative 9, M, negative 8, 1, C, W, those are the points, -9, 4, D, you can have Z, point Z, -3, -8, E, you can have point F, -10, -10, F, can have a point Q, -4, -4, -5. So when we say x-axis, they are actually referring to the Cartesian plane. So you've got a principle there, but it's you'll still have to have your graph paper. You'll work it on the graph paper to get the benefit of the experience of using a graph paper, and also get the benefit of knowing what happens there. So when you do it on a graph paper also, it will give you the right experience of getting that that experience of AB becoming A -B. So at that juncture, go through the assignment as we continue to build up on reflection. So I end the lesson. Have a nice time and bye.